Good morning. We have discussed inductive effect, mesomeric effect, hyperconjugation, and now next is electromeric effect. What is that? Electromeric effect. What is electromeric effect? It is a temporary effect involving the complete transfer of a shared pair of pi electrons of a double bond or triple bond in a molecule to one of the bonded atoms at the approach of an attacking reagent. So, in this case, when a reagent is attacking on a double bond or a triple bonded molecule, what will happen? When the reagent approaches the one of the pi electrons of the or one of the double bond or triple bond will be moved to one of the double bonded carbon atom or one of the double bonded atom, creating a positive charge on one atom and a negative charge on the other atom. So look at it here. It is a temporary effect involving the complete transfer of a shared pair of pi electrons in a double bond or triple bond to one of the atoms by the approach of an attacking reagent. That means, see here you can see that C double bond C, this is a pi bond. When a polar reagent means between the atom there will be a charge separation. Okay, one atom is slightly positive charge and the other atom is slightly negative, that type of reagent. So by the attack of a polar reagent, here you can see that pi electrons will be moved from one atom to the other atom. That means here you can see that this pi bond is shifting from or breaking from this carbon and it will move towards this carbon. Therefore, since the bond is moving away from, or the electrons are moving away from this carbon is getting a complete positive charge and the other atom, this atom is getting a pair of electron and a negative charge. This effect is known as electromeric effect. Now look at here, if one of the atom is more electronegative, the electron shift occurs towards the more electronegative atom. Suppose here you can see that both the atoms are carbon atoms. The double bond is between carbon and carbon. So the attacking reagent, when it comes here, the electron will be moved to here. That means it makes no difference. The electrons can go from this carbon to this carbon, or it can go from this carbon to this carbon. Anyway, you will get one carbon is positive charge and the other carbon is negative charge. But here you can see that the double bonded atom, one is carbon and the other one is oxygen. In this case, in the presence of a polar reagent, the pi electrons of the pi bond will always move towards the more electronegative atom. In carbon and oxygen, the more electronegative atom is oxygen. Therefore, the pi electrons will always move towards the oxygen. This reaction, this direction only the pi electrons will move. That means the pi electron will always move towards the more electronegative atom, oxygen atom, and you get a positively charged carbon, and a more electronegative atom will always get a negative charge. Okay. But here you can see that both are carbon atom. This bond can shift to here or it can be shifted to this carbon. It makes no difference. Types of electromeric effect. Look at here. First one is positive electromeric effect or plus E effect. What is positive electromeric effect or plus E effect? If the attacking species is an electrophile. What do you mean by an electrophile? Electrophile means positively charged species. If the attacking reagent is a positively charged species, the electrophile will get attached to that atom to which the pi electron pair is shifted. The meaning is that we can see that this is our double bonded carbon. Here is our electrophile. Electrophile means a positively charged species. If a positively charged species is coming to attack, and we know that when in the presence of electrophile, what will happen? This pi electron will be shifted to, since both are carbon atom, the pi electron will be shifted to one of the carbon atoms, and what we get, you can see that this carbon, since the bond is breaking from this carbon, carbon is getting a positive charge, and here is now it is a single bond, and this carbon is getting a pair of electron and a negative charge. The electrophile will get attached to that atom to which the pi electron pair is shifted. We can see that the pi electron pair is shifted to this carbon, and that means this carbon is negatively charged. Of course, the positive reagent will attack at the negatively charged carbon. Now, and at this stage, what will happen? Our Y plus, this is our electrophile. This electrophile will attack on this carbon, and what we get a structure like this, C, and here it is a positive charge, and here it is C, here it is that, and here it will become Y. This is what is called a positive electromeric effect. That means a positive electromeric effect. In positive electromeric effect, an electrophile is attacking. Electrophile means positively charged species. How it will attack? The electrophile will be get attached to that carbon, to which the pi electron is shifted. To this carbon only the pi electron is shifted. So in this carbon, the electrophile will come and attack. Of course, the electrophile is positively charged, therefore it will attack at the negatively charged carbon, and we get this product. Now, second one is negative electromeric effect, or minus E effect. What do you mean by minus E effect? If the attacking group is a nucleophile, what do you mean by nucleophile? The nucleophile means it is having a negatively charged species, or it has a lone pair electron. That type of species is known as a nucleophile. The nucleophile does not get attached to the atom to which the pi electron pair is shifted. Just opposite here, the electrophile is attacking to that atom to which the electron pair is shifted. Here you can see that the nucleophile does not get attached to the atom to which the pi electron pair is shifted. So look at it here. Now here you can see that this is our double bonded carbon. Here is our nucleophile. This is our nucleophile. Nucleophile means it has a lone pair electron and a negative charge. Okay. So you can see that first what will happen? The electron pair, the pi electron pair will be shifted to one of the carbon atom. So we get here it will be like this. Here it is positive charge, and here it is negative charge. Now you can see that this nucleophile. Now the nucleophile will come is that minus. This is our nucleophile. Of course, this nucleophile will attack on this carbon positively charged carbon, and what we get C. Here it is Z, and here it is C. Okay, it's a pair of electrons. So we get this compound, this type of structure. So this is what is called a negative electromeric effect. In negative electromeric effect, a nucleophile is attacking. The nucleophile does not attack the carbon to which the pi electron pair is shifted, but it will go to the other carbon. That means the nucleophile will always go to the atom which has a positive charge, because the nucleophile is having a negative charge, so it will always go to that carbon or to that atom which is having a positive charge. But the electrophile will go to that atom to which is having a negative charge, because the electrophile means positively charged species. The positively charged species will always go to that atom which has a negative charge. So this is what is that positive electromeric effect and negative electromeric effect. Now look at here, for negative electromeric effect we can take an example. Negative electromeric effect, or the commonly the entire electromeric effect can be explained using an example. We take acetaldehyde. Acetaldehyde is CH3C double bond OH plus it is reacting with the hydrogen cyanide HCN. Okay, that means in HCN, H is what is that, positive, and CN is negative, H plus, and CN is negative. That means this is electrophile, this is electrophile, H plus is electrophile, and CN is nucleophile. So look at here, the electromeric effect. What do you mean by electromeric effect? Now we can see that CH3, that means CH3 means here you look at here, what is the actual structure? This is CH3, and here it is Okay, CH3, okay, no need, we are taking this bond only. So CH3, now our double bond is this one, C double bond O and H. Same only, same structure I have written like this, CH3, C double bond O, H, plus we are adding HCN, H plus and Cn minus. Now this is our double bonded part. And we know that when double bonded part, one is more electronegative, here oxygen is more electronegative, therefore the electron shift will always occur, the electron will shift will always occur, the pi electron will always will be shifted to more electronegative oxygen, correct? That means what we get CH3, C, here it is H. Since the bond is moving towards oxygen, oxygen is getting a pair of electron and a negative charge. Here it will become a positive charge. Clear? That point we have noted. If in a double bonded species, by the attack of a polar reagent, this is a polar reagent. When a polar reagent is approaching a double bonded group, what will happen? You can see that the electron, if the double bonded group, if one atom is more electronegative, then the pi electron pair will be shifted to the more electronegative atom. So the pi electron pair will be shifted to oxygen. And now we can see that this is our reagent H plus and Cn minus, as we have studied. Positive electromeric effect. What do you mean by positive electromeric effect? That means the positive part, this positive part, the electrophile will attack the negative part of the structure. And what do you mean by negative electromeric effect? The negative part, the nucleophile will attack on the positively charged part. So what we get? We get CH3, here it is CH, and what will come here? Cn will be here, and here it will become OH. Okay, so this structure can be written as CH3, CH, Cn, OH. Clear? Now H plus is going to oxygen and Cn is coming to carbon. This is what is electromeric effect. Okay, so positive electromeric effect. This is positive electromeric effect. What do you mean by positive electromeric effect? The electrophile of the polar reagent, will go to that atom to which the electron pair is shifted. So H plus will go to here, and the nucleophile will go to the other atom. This is what is called electromeric effect. Clear? Okay, thank you. We continue in the next class.